I will share my screen. So is that whiteboard is visible to everyone? Okay, fine. Note down. No? The incremental fuel cost for two plants. The incremental fuel cost for two plants are given by dC1 by dP1, that equal to 0.1 P1 plus 20 rupees per megawatt hour, and dC2 by dP2 equal to dC2 by dP2 equal to 0.15 P2 plus 22.5 rupees per megawatt hour. The system is operating at who is someone is there in waiting room 17777. Whose number it is? One second. 17777. Is there anyone login with that name? That roll number? Okay, fine. Right, you can continue. The system is operating at P1 equal to P2 equal to 100 megawatts and dou P1 by dou P2 equal to dou P1 by dou P2 equal to 0.2. Find the penalty factor. Find the penalty factor for plant 1. Find the penalty factor of plant 1 and penalty factor of plant 1 and incremental cost of, or simply you can calculate penalty factor of 1 and 2. Penalty factor of 1 and 2 for each plant. We know the formula of penalty factor, right? L equals to, yesterday we derived. Here two plants are given. Right. So you know the formula for penalty factor, and they given dou P1 by dou P2 as 0.2 and P1 P2 operating at P1 equal to P2 equal to 100 megawatts, and they given the incremental fuel cost for each plant DC1 by DP1 and DC2 by DP2. So you have to note down the given data. given data, the incremental fuel cost of plant 1 and incremental fuel cost of plant 2, right? And your P1, P2 and dou P1 by dou P2. Then you have to take the penalty factor for plant 1 as L1 and for plant 2 as L2. Okay, already they given dou P1 by dou P2. So therefore L2 is equals to, you can directly calculate your L2, that is 1 minus dou P1 by dou P2. Already they given directly dou P1 by dou P2. So by substituting, you will get penalty factor for plant number 2. By using this, you can calculate penalty factor for plant 1. Do it and tell me L1, L2 values. How much? 1 by 0.8.
0.98, sir.
Total answer 1 by 0.8, that is 10 by 8. Around it should be 1 point something.
$1.02, sir.
1.02. 10 by 8. 8 ones are 0.20. I think 1.2 ma. 1.2 something. 2.3 or 2.4.
1.25, sir. Sorry, sir.
Right. 1.25. Okay.
Yes, sir.
1.25. Right. Then by using this L2, that is a penalty factor for, this is your penalty factor for, you have to mention for plant 2. Then for plant 1, you need to calculate L1. So how should you calculate L1? We know that condition of optimal operation. So what is the condition for optimal operation? L1 dC1 by dP1 is equals to L2 dC2 by dP2. So will you substitute the values of P1, P2, L2? That is L1 into what is dC1 by dP1 given as 0.1 P1 plus 20. That equals to L2. Already you are calculated as 1.25. dC2 by dP2 they given in the problem as 0.15 P2 plus 22.5, right? So already in the given problem they mentioned P1 equal to P2 equal to 100. So in this equation you can substitute the value of P1 P2 as 100, and therefore finally you can obtain the penalty factor for plant 1, that is L1. Right here what we did, for the given data, just note it down, the incremental fuel cost for plant 1 and plant 2, and at which generation and at which load it should be going to operated. That is, the system operated at P1 P2 equal to 100 megawatts, and dou P1 by dou P2 given as 0.2, the change, and we need to calculate the penalty factor for plant 1 and 2. So by directly giving dou P1 by dou P2, we can calculate L2 by substituting in the formula of penalty factor. There itself we are getting as 1.25 as the penalty factor for plant 2. This is for plant 2. And for plant 1, by using the condition of our optimal operation L1 dc1 by dp1 is equals to L2 dc2 by dp2 by substituting the given data L1 into 0.1 P1 plus 20 that equals to L2 already we calculated as 1.25 multiplied with your dc2 by dp2 equation whatever they given as 0.15 P2 plus 22.5. So there in that equation you can substitute the values of P1 and P2. You can obtain the value of penalty factor for plant 1. So calculate and tell me the value of L1. How much the value? 2.23. Sirisha, okay ma. Is there anyone got the same answer or different? L1 value.
I got 1.35, sir.
1.35. Still, is there another values from anyone? I need one more answer so that we can cross check which one is correct. Do it quick. Just you need to substitute 0.1 into 100 plus 20 on left hand side and on right hand side 1.25 into 0.15 into 100 plus 22.5. Therefore L1 equal to, it should be around 1 point, but the next digits I don't know, but it should be 1 point something.
1.56, sir.
1.56. Still, is there any answers? 1.56 penalty factor for plant 1. Sirisha, you can check once more. It's 1.56.
Okay, sir.
Yeah. Remaining people, Chendulal, Uday, Shibi, okay, you joined just now. Srinivas, Abdul, Shiva, Bhargav. Are you doing? Respond. All of them are doing or not? Having any doubts while doing the solution? Bhargav,
Yes, sir.
they're doing the solution.
Calci not there, sir. I am doing sir.
Okay. Ashish,
Sir,
doing?
joined just 2 minutes before, sir.
Okay. Shiva, are you there? You are presented. Shiva, doing? there? Rajeshri. 213 Rajeshri. Okay, doing. Okay. Yeah, Shiva. Okay, doing. Having the same answer 1.56. Okay, okay. Right, we will move on to the next problem. So shall I clear this white screen? Yeah, okay, no, fine. 1.56. So 1.56 is the final answer for penalty factor of plant 1. Right. Note down the second problem. The equations of input cost of 3 power plants. Now we are moving on to 3. Until now we did for 2 plants. Now it should be shifted to 3. The equations of the input cost of 3 power plants operating in and supplying power in a system network are obtained as, I will repeat once again. The equations of input cost of 3 power plants operating and supplying power in a system network are obtained as C1 equal to 0.06 P1 square plus 15 P1 plus 150 plus 150. Similarly, they given C2 as 0.08 P2 square plus 13 P2 plus 180 and C3 as 0.1 P3 square plus 10 P3 plus 200. All are in rupees per hour. The incremental loss rates of the network, note down, the incremental loss rates of the network loss rate of the network with respect to the plants 1, 2 and 3 are 0.06 comma 0.09 and 0.1 per megawatt, full stop. Or you can just extend it as per megawatt of generation respectively. Per megawatt of generation respectively, full stop. Now determine the most economical share. Determine the most economical share determine the most economical share of a total load of a total load of 120 megawatts. Some of them are in waiting room. Okay. Total load of 120 megawatts, which each of the plant would take up for minimum input cost of received power in rupees per megawatt hour. Full stop. So once check the problem, I will repeat once again. The equations of the input cost of three power plants operating and supplying power in a system network are obtained as follows. C1 equal to 0.06 P1 square plus 15 P1 plus 150. C2 equal to 0.08 P2 square plus 13 P2 plus 180, and C3 equal to 0.1 P3 square plus 10 P3 plus 200. Right. Now what they are given another the loss rates of each plant has 6%, 9%, 1%. Nothing but they given in decimals as 0.06, 0.09 and 0.1 per megawatt. Full stop. Right. So now what they are asking, determine the economical share of total load of 120 megawatts. Right. And which of each plant would take up for minimum input cost and received power in rupees per megawatt hour. So that is the thing they are asked. So where you need to calculate the value of P1, P2, P3, right? And also you need to calculate the penalty factor. Sorry, not penalty factor. You can make it as a differentiation, that is dou L by dou P for any plant. Anyone you can take. Anyone in the sense which is having the least economical share. While after you calculating P1, P2, P3, you can identify which one is having the lower share so that you can take that differentiation. That is dou C1 by dou P1. That is rupees per megawatt hour. Here there is no question of penalty factor. It's like your first half of your unit 3. Will you do this? Just you need to take the different. I will give the procedure, right? You try to solve it. So as per given data, you have to write all these equations and make them as an incremental cost as by differentiating with respect to corresponding dp1 and dp2 and dp3. Right now you are obtained the incremental cost from the given equations. Now we know for economical scheduling the condition is nothing but our coordination equation, dc1 by dp1 equal to dc2 by dp2 equal to dc3 by dp3, right? So by using this equation you can make equate all these three equations, and from 1 and 2 you can find p1 in terms of p2 like that, and you can equate another two equations. So from these two equations, you can calculate P1, P2, P3 as a separate. Right, and also here total you obtain the three equations. The third equation is simply from the given statement as determine the economical share of total load. They given as total load, that is P1 plus P2 plus P3. How much? 120 megawatts. So this is your third equation. Right, here you may get P1, P2, P3. You may equate two equations, you will obtain the resultant two equations, and this is the your third equation. So three equations with three unknowns. Solve it and find out values of P1, P2, P3. Will you do this? Able to understand how to solve this?
Sir.
Right, do it and calculate.
Yes, sir.
Find out and tell me the answers. Meanwhile, I will do it slowly. First one 0.06 P1 square. Differentiation with respect to P1. 6 2 12. 0.12 P1 plus 15. 150 is constant 0. Now the second one 0.16 P2 plus 13. Third one 0.2 P3 plus 10. Remaining all of you do it quickly and you can cross check the answer. Now, as per our condition for most economical scheduling, the condition for most economic scheduling, right, our coordination equation dc1 by dp1 equal to dc2 by dp2 equal to dc3 by dp3. So by substituting these equations, let us take as 1, 2, 3. By substituting all these three equations, 0.12 P1 plus 15 equal to 16 P2 plus 13 equal to 0.2 P3 plus 10. Now you can equate any two equations. Let us equate your first and second. That is 0. This is, you can take it as some equation number 4. P1 plus 15 equal to 0.16 P2 plus 30. Now the equation will be turned with respect to P1, P2. How I can write this? 0.16 P2 minus 0.12 P1, that equals to 2. 15 minus 13, 2. Now 0.16 P2 equal to 2 plus 0.12 P1. Therefore, P2 equal to 2 plus 0.12 P1 by 0.16. This is your value of P2 in terms of P1. All right. Now, similarly, you can equate another equations. That is, we can equate 1 and 3 now. Therefore, your P3 will come in terms of P1. So 1 and 2, that means first equation and the third equation. 0. Here I will do 0.12 P1 plus 15 equal to 0.2 P3 plus 10. How can we 0.2 P3 minus 0.12 P1 equal to, and it will become as a negative 0.2 P3 minus 0.12, that is 15 minus 10, 5. So from this P3 is equals to 500 by dividing, no. So you can simply go for 5 plus 1 to P1 by 0.2, right? Next, P1 plus P2 plus P3 equal to 120. Now substitute your P2, P3 in this equation number 3. Substitute P2 and P3 in equation number 3. That is P1 plus 2 plus 0.12 P1 by 0.16 plus 5 plus 0.12 P1 by 0.2. That equals to how much? 120. Now entire equation is in P1. Now calculate the value of P1. By using this P1, calculate value of P2. By using this P1 again, calculate the value of P3. Calculation is very important. Even though entire your procedure is correct, if your answer is wrong, you may lose 2 marks. So don't do any mistakes in calculation. Once you obtain P1, P2, P3, substitute any value which is having the lowest out of these 3 in equation 1 or 2 or 3. So that we will get the minimum input cost of received power in rupees per megawatt hour. Now these are the units are rupees per megawatt hour. We have one more derivation. Up to this, your unit number 3 is finished as per your syllabus. But maybe sometimes if they wanted to make the paper more complicated, they may ask the loss coefficients sometimes. So I will cover that loss coefficients derivation on tomorrow class and some model problems on that derivation, so that we can wind up unit number 3 by tomorrow. How much time taken for unit 1 is equivalent to the units of 3, 4 and 5. The last 3 units are almost equal to your unit number 1. Such a vast syllabus we are having in unit number 1. Both single area load frequency control and 2 area load frequency control and steady state frequency errors. Everything in unit number 1. That unit number 1 should be splitted into 3 units while we are studying PSOC in our B.Tech. Now for you people, they should be merged to only 1 unit. Do it fast and tell me the answers. P1, P2, P3. how much the values of P1? If you calculate P1, that should be enough. Easily you can calculate P2, P3.
Sir, P1 is equals to 30.106.
1 second. P1 equals to how much?
35.106.
35.1. Okay, 106. We can keep it as 35.1 megawatt. And P2?
38.85, sir.
38.83 megawatt. And summation of these two by subtracting from
P3 is
your
equals to
total load.
46.044, sir.
46.04. Okay. Now adding of all these three is 120. 35, 70. Right, almost
Sir,
120. Okay. So all of you got the same answers or any deviations? Check once. So if all of them are got same answers, now your P1 you can take and substitute in your incremental fuel cost. That is DC1 by DP1, where 0.12 P1 plus 15 and 0.12 into your P1 is the least value 35.1 plus 15. How much? That is your answer, rupees per megawatt hour. Yeah, okay, sure, same answer. Now calculate DC1 by DP1. That is the thing what they are asking, which each of the plant would take up for minimum input cost. This one, minimum input cost and received power in rupees per megawatt hour. So we need to calculate this DC1 by DP1. How much the value of DC1 by DP1?
19.2, sir, rupees per megawatt hour.
Once again, 90 or 19?
19, sir.
19.21.
212.
Okay, rupees per megawatt hour. Right. So all of you complete, and anyone can take the screenshot of today's attendance, no, and keep post in our group. So that tomorrow we will wind up unit number 3 by doing last coefficients derivation and some problems on it. Keep posted. Okay, thank you all. I think today some batches are scheduled for review. Review in the sense for their pending works need to be complete. By today evening, I will share the rough documentation of your mini project draft so that you can maintain that documentation with you and submit in the next week. Okay, and for your technical seminar also, all of you prepare the documentation and submit it to my mail ID So therefore, I can schedule your technical seminars. Already I shared the Google Sheet. Okay, so all of you fill that by tomorrow. Tomorrow is the last date. There is no further extension. So already I given the permission to edit that sheet for 2 members in each team. So you people contact with your classmates, your teammates. Those who don't have permission, you can inform your technical seminar title to the team. Okay, who are given the permissions, so that they can enter. The responsibility is individual, right? Let us take Uday. I think Uday I did not give in permission for them batch. I given permission for Shivasri. So Uday responsibility is he need to verify whether his technical seminar title is entered in the sheet or not. So it's the responsibility of the Uday. Like that in each team, it's their individual responsibility to ask and request your teammates to enter that in your Google Sheet. Okay, and make it finalized by tomorrow evening. If any challenges you are facing, you can inform me. Right after tomorrow, there is no further extension of the timelines for your technical seminars or mini projects. Many projects documentation should be complete by festival. After festival, there is no mini projects discussion within us. Okay, only technical seminars. Fine. Thank you, Ma. Thank you all. We have to prepare Srinivas. We have to prepare document or PPT for seminar. Both, Ma. Document you need to submit and PPT also you need to submit. As an initial state, you need to submit your PPT to my mail ID by indicating the subject as your roll number and technical seminar topic. That's it. These are the 2 areas you need to mention in the subject, so that I can quickly sort out who are submitted in my mail ID. Okay, your subject is your roll number hyphen technical seminar topic. That's it. So that I can understand, I can download and keep it in one folder with your roll number, that name of the title. Okay. And the documentation you need to prepare later, no issues. But at the end of January, you need to submit the hard copy in the department. Okay, clear? Is there anyone still having any queries regarding your mini projects or technical seminars? It's an individual, each one have your own 100 marks for that documentation and PPT preparation and your presentation communication skills. Okay, shall we wind up today's session? Thank you, Ma. Thank you all. If still anyone having any queries, you can contact me or you can contact our guide. Thank you all.